Welcome everybody back to the Maybe Observatory here at Bethel College. My name is Caden MacArthur, and today I'm going to be talking about some astronomical events for the month of March, a short math lesson, and showing off some of our images from our imaging class this winter. March, unlike February, actually has some events that are worth actually seeing. Last month we were very quiet and clear, which made imaging here at the observatory on certain days a very smooth experience. First up on our list of events is Comet 12P Pons-Brooks. This is a periodic comet similar to the famous Halley's Comet and will somewhat light up our skies for the next 2 months. As the month goes on, the comet will grow increasingly brighter in our evening sky just after sunset. However, in order to see this, you must be in a very dark area with very little light pollution. While this is a brighter than normal comet, at its peak it will be around 4.5 magnitude on the brightness scale, which is very close to the naked eye limit. Allow your eyes to adjust to the darkness for several minutes and bring a pair of binoculars, and you might just see a green smudge in the sky. Viewing comets can be disappointing at first, but when your eyes correctly adjust, comet tails can span vast distances in the sky and are quite the sight to behold. For our deep space lovers, March will be a great month for you. On March 9th, you will have the opportunity to observe all 110 Messier objects in a single night. This is due to the position of the Earth in its orbit around the Sun, and the fact that there will be a new moon at this time. On March 20th, we will experience the spring equinox, where our day and night will become the same length, marking the end of meteorological winter. For you inner planet lovers, Mercury will finally be visible in the evening hours instead of in the early morning. You can find Mercury above the horizon just after sunset. But you must be quick, because not only will it set fast, but after a couple of days it will be no longer visible due to its orbit. Venus, however, will stick too close to the Sun in the morning, and you will find it tough to observe it. March 25th marks the start of eclipse season with a penumbral eclipse. While this is not as impressive as a total lunar eclipse, we will see a small darkening of the moon during this event. This eclipse is the precursor to the next great solar eclipse on April 8th, where we will see about 90 coverage of the Sun here in Newton. But we will discuss that in our next video and talk more about eclipse seasons and how ancient astronomers could predict eclipses happening in advance. To celebrate the coming spring equinox, did you know that ancient mathematicians used these events to measure the size of the Earth in 250 BC? During that time, a rumor had circulated for years that during the summer solstice in a city called Syene, that there is a well that would be directly illuminated at the bottom with no shadows. Eratosthenes of Cyrene traveled to the city during the solstice to see it for himself. When he saw that happening, he had an idea. But it would have to wait for another year for the next summer solstice. So I'm going to show you in this simple diagram how Eratosthenes calculated the circumference of the Earth using nothing more than a stick and a shadow. So during the summer solstice, the Earth is at an angle in its orbit where the Sun is hitting the highest most latitude of its surface. Coincidentally, the city of Cyrene was built right on this highest latitude. This highest latitude is also called the Tropic of Cancer. So here in Alexandria, where this second stick will represent, is where Eratosthenes is located. Eratosthenes heard that during the summer solstice, for a couple of minutes, the city of Cyrene, that there are no shadows cast. This is because the sun is hitting directly overhead. So after hearing this rumor, Eratosthenes set out to understand why this is happening. This was during a time where it has been theorized that the Earth is round, but it hasn't been completely proven yet. So here is the exact step for step what Eratosthenes did to calculate the circumference of the Earth from within 1% of today's actual agreed upon distance. He assumed that since the sun is so far away that the sun's rays would come in a straight line. These two lines pass through Alexandria and Cyrene respectively. As you can see in Cyrene, you almost cannot see the stick because I drew over it. This is because the sun's rays are coming in at a completely straight line, so it won't cast any shadows. But here in Alexandria, since this area is curved, this stick will cast a shadow during the summer solstice because it is not in direct parallel with the sun's rays. And because of this angle right here, Eratosthenes, during the exact same time the next year, measured this angle to be 7.2 degrees. This is significant because 7.2 degrees is about 1/50th of a circle. But you might be asking, that doesn't make sense yet. Well, So drawing a line from this stick straight down to the center of the Earth, where these two lines will meet, these two sticks will meet, using the law of interior and exterior angles, this 7.2 degree angle also means that this is also a 7.2 degree angle. So now he can go and measure this part of the Earth, and then he can determine the circumference of the Earth. So what he did is he hired pacers to walk this distance from Cyrene to Alexandria in a completely straight line. Because of this, and since there are some discrepancies in their measurements, this is why there is a slight error in his calculations. But for the tools that he had at the time, it was still very close. So in today's measurements, that measurement came out to about 800 kilometers. From there, it's nothing more than some simple multiplication. We take 800 times 50, which gives us about 40,000 kilometers for the entire circumference of the Earth. Now, this would be a perfect measurement if the pacers had an exact measurement from here to here, but when they had to cross the Nile several times, it is very hard to get an accurate measurement. And we also know at this point that the Earth isn't a complete circle. It's squished in the middle due to centripetal forces because of its spin. But this 40,000 kilometer distance is within 1% of today's agreed upon distance and circumference of the Earth. And that is how Eratosthenes, using nothing more than a stick and a shadow, discovered the circumference of the Earth and proved that the Earth was round. Before we end off, I wanted to show off some of our new images taken this past month with our telescope here at Bethel. This is the Rosette Nebula, and it was the main imaging focus for our small imaging class here in this past winter. Well, that is all I have here for you guys today. I hope you enjoyed learning about some of the things up in March, a short math lesson on how Eratosthenes measured the circumference of the Earth with nothing more than a stick, and enjoyed looking at some of our images that we have produced here in the past few months. I hope you all enjoyed, and I will see you all next time.